Okay, so today, actually yesterday, we discussed very basic. I didn't teach anything yesterday, but we got a high level overview. Today, I'll go into the topic. We'll discuss what is a model, what do I mean by training a model, and uh, we'll try to actually implement a model by using linear regression and logistic regression. And I will introduce you to what is neuron. Today, this is the topic. You'll understand what is a neuron by the end of the day, and you'll get an idea about what is an artificial neural network. Just an introduction. Tomorrow, we'll have a deeper discussion on artificial neural network, and we'll see what is deep learning tomorrow. So today, let us start with machine learning. Okay. Normally, I will not use presentations, but just to show you some diagrams. Very rarely I will use presentations. Let me just go through this presentation and start the discussion. Okay. If you have any doubts, please interrupt me and ask your questions. Don't hesitate to stop me. Okay. What is machine learning? Machine learning allows us to teach computers how to learn from data and make predictions based on patterns they discover. So basically, in machine learning, we teach computers how to make predictions from data. Okay. Actually, machine learning is a subset of artificial intelligence that focuses on development of algorithms and models that enable computers to learn and make predictions or decisions without explicit programming. So without explicit programming, I want to make predictions. Based on data, I want my machine to learn something. So ML is all about development of algorithms and models. Okay, fine. Now, let me just do a funny thing. You'll understand what is machine learning, what is difference between traditional learning and machine learning. Okay, traditional programming and machine learning. So this is the data set. We're having X and Y. Okay, if I give you this data set, you are a human, right? Can you tell me the value of Y for X equals to 10 based on this data? If X equals to 10,
20.
20.
20.
Y is 20. So you are a human. You are able to identify some pattern in this value of X and Y, and you are able to give a answer. Okay, what about this? What is the value of Y when X is 10? 30. Simple, right? But now say this and tell me what is the value of X. Sorry, what is the value of Y when X is 10? This boy is saying like this, right? Anybody can answer me? What is the value of Y when X is 10? By seeing this data, can you tell me? Anyone?
3.5.
Oh,
2.5.
very good. Exactly 3.5. So your human computers. So mostly for humans to identify this pattern, it will be a little bit tough, but of course we can find it. But for computers, they will be able to find the relationship very easily. How? There is a technique which we use called as gradient descent. By using a technique called as gradient descent, we can identify the relationship between X and Y. So if you see, the relationship between X and Y will be like this, according to this data. So if I substitute 10, it will become 5 minus 1.5, 3.5. Fine. This is the technique, gradient descent. Okay, so I will tell you how this works. But before that, in linear algebra, normally in our traditional programming where we use something like algebra, suppose if I give an expression like this, y is equals to 2x plus 3, and if I give array of x values, of course, we can compute array of y values. By using traditional programming, we do this, right? Okay. But in machine learning, what we do, we give array of x values, array of y values. In machine learning, we have to find this equation. That is the difference. Okay. In a traditional programming, we will be given an equation and x values. We will compute y. Of course, it's just substituting the values of x. We'll compute y. But in machine learning, we give x and y values, but we have to come up with equation. That is the difference between machine learning and traditional programming. Based on the data, the algorithm will learn and find this equation. Okay, how? We'll see. So if you see in traditional programming, what we do, we give input and also our logic algorithm, and we finally get our output. But in machine learning, what we do, we'll give our training input first, not the original input. We have to perform training first. We'll give our training input first and also the expected outputs, and then train our model. Initially, we have to do training. So after performing training, the output of training will be the something called as ML inference. Okay. So maybe we will not write the logic. In traditional programming, we will write the logic. But after training, the ML inference will be created. The output of ML training is a ML inference. So this logic, it will be automatically calculated by the algorithm. And after training is over, if I just give the input, it will give a predicted output. Remember the word I am using. Machine learning algorithms will do predictions. The predictions might not be accurate. Okay, fine. So that is the difference between traditional programming and machine learning programming. Now, just to talk about machine learning, normally as a kid, my kid, how did we make him to learn? Let's say we'll show some different kinds of fruits and tell, okay, this is an apple, this is a banana, this is orange. So kid will identify once we actually tell him, right? So like that, after training is done, if I give a bunch of fruits to my kid, he will be able to identify each of the fruit. So initially I have to train. Okay, I have to tell this is banana, this is apple and all. But after training, if I give a bunch of fruits, he will be able to identify. Similarly, in AI, if you want to train AI, suppose if you are training AI to recognize apples, what you have to do is you have to show various apples, different kinds of apple images, so that it gets trained to identify apples. So what I mean is, actually, if you want to train a machine learning model, you need huge data. If you are training a model to identify apples, you need different kinds of apples. You need huge data, right? Machine learning needs huge data. So if you want to perform machine learning, it needs huge data, lots of computational power, and you need algorithms actually. Okay. Now, once we understood that machine learning is very costly, it needs huge data, huge computing power. We'll actually do machine learning, but let us see the difference between machine learning, artificial intelligence, and deep learning. Yeah, these are the terminologies which you will be hearing mostly. Let us try to understand the differences and understand each of them. Okay. What is artificial intelligence? See, artificial intelligence, you can see it is a superset of machine learning, deep learning, etc. So this diagram says that there can be artificial intelligence without machine learning also, right? Yes, this part is there. So I want to give an example of what is an example of artificial intelligence without machine learning. One popular example is chess. In olden days, like even before 20 years also, I used to play chess. The chess application is not developed using machine learning earlier days. They have written some rule-based program. Maybe if this condition is satisfied, do this, else do this. So like that, they have written a rule-based program and I played this chess. But whenever I was playing this chess, I felt that this has some intelligence, just like human. Yes, of course, it is displaying intelligence just like human, but this was developed to be a rule-based application. As it is also displaying intelligence just like human, I can say that this chess application is an artificial intelligence based application. But it is not a trained application. It is not using any training. It is just a rule based if else conditions, etc., will be there in this chess program. But nowadays, actually, uh, even from few years as well, there are chess applications. For these chess applications, what they have done, they have created a model. So different players might have played differently, right? With that data, let's say this is data where there are steps about what players have taken. They have actually trained a model with this data and they have created a trained chess model. Okay. Now once this trained chess model is trained on data, if I give any input step, it will take the next step. It will predict what should be the better or best next step. So yes, if you are actually creating a chess model after training, after you train the model, then I can say that the same chess application is displaying artificial intelligence, but it is using a trained model behind the scenes to predict the next moves, right? So that is the reason why you see in this diagram, artificial intelligence is superset. Machine learning also is used for creating applications which display artificial intelligence. So it is subset of artificial intelligence. And deep learning is again a subset of machine learning, which uses a concept called as neural networks. So actually, whenever I saw this term deep learning, I thought, oh, deep learning is nothing but learning, machine learning in depth. No, no, no. This is not machine learning in depth. It is a different kind of learning which we can do for our machines. Okay, we'll understand what is a neural network, what is deep learning. We will understand either today and or tomorrow we have an in-depth discussion on deep learning. But right now, just understand that deep learning is a subset of machine learning. Okay. Yeah. Any questions? Yeah, Connor, tell me questions.
So, as you told, like same chess game we have made via training of the different players' data. That means
Hmm.
this new chess game will be as good as all the player combined. That means
So
if
this,
you are preparing a chess game using ML, you maybe have a different high quality player data. I have a low quality player data.
yeah,
So so now the model you trained in a chess versus what I trained in a chess, your
so
model will perform much better, right? Or is it
correct.
like
So
go beyond the expectation? Just It's like a summation of as good as my training data is, or
Correct.
it will like perform plus one. I'm like that question I'm asking, like this model are intelligent enough, like okay, right now whatever the players data I have given, but once that model is getting trained with the summation of the all players data, they will outperform all these players, or there will be a like not much like.
Okay. So it all depends on the data, whatever you are feeding. So during this training process, you'll be feeding huge data to this model. It will learn some patterns. Okay. Then based on the patterns it learns during training, it can do predictions, right? So it all depends how the prediction is good based on the algorithm which you are using. There are a lot of machine learning algorithms. Okay. So based on which algorithm you are using and based on some parameters. So whenever we are training our model, there will be different parameters for training. So based on the parameters, what are you configured during training process, the predictions will be accordingly, right? So it all depends on data and parameters. What are parameters I configure and what quality data I give. So yes, of course, after training, this game might be even better or might not be better. It is all about predictions. Okay.
Okay, got it.
Yeah. So good. Now you understood about these things. Now let us try to understand one simple algorithm called as linear regression algorithm. I wanted you to visualize what do I mean by training? What is a model? I was using the words model, training, and all. So as a person, I wanted to always visualize whatever I do. So I'll make you visualize what is a model. What do I mean by training? Everything I will give you clearly. Okay. So let us take an example. Let's assume that I have this data. Okay. This is some data in tabular format. I have area of houses. This is house area, home area, and price of this home with this area. So for 2,600 square feet area, the cost is this much. For 3,000, the cost is this much. So assume that I have home prices data, and right now I'm showing only 5 rows. Assume that you have huge data with areas and prices. Now what I want to do is, I want to feed this data to an algorithm. I'm using the word algorithm. Some algorithm. I want to feed this data to some algorithm so that it will learn from this data. And after training is done, I want to use this trained algorithm to do predictions. Okay. So let us try to understand how it works. Okay. So first of all, what we need to do is once we have data, what we need to do is we need to identify, is there any relationship between these data points? Anyways, I have right now area and price. Assume that I try to plot them on a graph. So these are the data points. I plotted area on x-axis and price on y-axis. So I thought if I can draw a line passing through all these dots, all these points, then I feel like I have identified some relationship between area and price. So I try to draw a line, but single line will not go through all data points. What I want is I should be somehow able to find a best fit line. I wanted to actually use best fit line. I want to find the best fit line. Perfect line will not be there, only best fit line. So suppose if if I identified this line to be a best fit line, then what? Suppose if I want to find for 3,000 square feet data, what is the price? I can draw a line here I can draw a line here and I identified, okay, this can be the predicted price for 3,300, right? So the main interest is here. I should be somehow able to identify the line. And as you know, all of you are mathematics students, you should be able to find the relationship between line equation is y is equals to mx plus c. So you have to find this equation if you are trying to predict a line. In this case, as the data is having some linear relationship, I thought a line will be appropriate. So I have to somehow predict this equation. I have x and y values. So what? I should be able to find what is the value of m and what is the value of c, right? So I guess in mathematics, you know, m is called as slope and c is called as y-intercept, right? So we have to find this data. We have to find this m and c. That means I should have identified the best fit line. How? How is it? How to actually find it? Let me just tell you the idea first. I'll tell you the idea. What do I mean by a best fit line? Let me try to define the best fit line first. How can I make sure that this line is the best line? So what I want to do is actually see, I can draw one more line like this. Maybe I can say this is also a best fit line. Okay, don't mind the curves. Assume that this is a straight line. There can be multiple lines possible connecting all. But what is a best fit line? So what I need to do is, if I have to tell that this is the best fit line, I can calculate the difference between this point and this line. I can say that this line is deviating this much from the actual point, right? Or I can say that there is a this much error. Length of this line, I can call it as an error. So there is a error, and here also there is a little bit error. This is error. So there will be some error from every data point. So if I have to say that this is the best fit line, I have to calculate mean of error. Mean. Mean means average, you can think, right? So right now there are
Yeah,
how
we
many data
to
points?
find
One, two, three, four.
minimum error.
Mean.
Yeah.
That
Okay.
means there are first of all I have to find the mean error. Okay,
Mhm.
there are 5 data points right now. I have to calculate some sigma of errors and then divide by n. That means it is a mean of error. I want to make sure that mean of this error is minimal. So for whatever line this mean is minimal, I can say that this line is having minimal error. So I can say that this is a best fit line, right? But a small change I will tell you. See, this error is negative. This error is positive. If you see the values, if I calculate sum of negatives and positives, again, I will not get the exact error, right? So the data scientists have identified if we square the errors, if we square the errors, and if I calculate after I'll square the errors and calculate sum and then divide by n. This is called as mean squared error. I'll get a mean of squared errors. So instead of taking mean of errors, we can also take mean of squared errors. So for whatever line this mean of squared errors is minimal, then I can say this is the best fit line. So somehow I have to use an algorithm to make sure that it will find a line where mean squared error is less. Okay. How? Let me again tell you how it is. So as I told you, mean square error has to be minimal. How? So normally line equation will be like this: y is equals to mx plus b. In this case, y is price. Price is equals to m into area plus b. Now we have to find the value of m and b. How do we find? Let me tell you the idea. Then we can have a discussion. I'll tell you the base idea first. Okay, this is the data, whatever I have. And I know that there is a linear relationship between area and price. Price is equals to m into area plus some c. Okay. Now my main duty is to find m and c. If I can find m and c, I think I have identified a line, right? So what we will do is we want to write an algorithm where it will start with some random initial values of m and c. Let us say it started with m is equals to 1, c is equals to 1. Okay. Then what I will do, this is the data, right? I'll take first data, first line, and substitute area here. And substitute area here. M is 1, C is 2 initially. I just started with random M and C values. So what will be the value of price? M into area is, M is 1, area is 2600 plus 2. What is the value of price I got? 2602. But what is the actual price according to this data? 55,000. Sorry, 550,000, whatever. Right. So there's a difference between this and this, right? I will say that this is the error for first line. Similarly, I'll calculate again for same value of m is equals to 1 and c equals to 2. I will calculate the price. So maybe for this, how much? M 3000 into 1, that means 3002. But actual predicted price is what? If 565,000. There is an error. So like that, for each and every row, I'll calculate errors. Some errors might be negative, some errors might be positive. So I'll compute sum of delta. I'll say error is delta square, and then divide it by n. So I'll get mean square error now. Let's assume that the mean square error right now is some 25,000. Assume that the mean square error is 25,000, for example. Okay, so when the value of m is 1 and c equals to 2, there is a mean error of 25,000. So then the algorithm, it has to adjust the value of m and c. Then let's assume that the algorithm adjusted the value of m as 100 and c as minus 200. For example, I'm saying the algorithm has to adjust the values of m and c and then redo the same process for each and every line. Calculate the error and square the error, sum it, divide by n. Now maybe the error is 23,000. For example, I'm saying. So like that, the algorithm has to adjust the value of m and c, calculate the mean square error. Now you may ask, hey, how do we adjust these values of m and c? How does the algorithm adjust? There is some mathematics behind the scenes, and internally they use calculus. And I hope everybody might be knowing derivatives in your 12th standard or 11th standard. You might have understood about derivatives. So internally, they will derive at the values of what could be the m and c. Algorithm internally uses derivatives. We don't want to go into that derivatives. So algorithm will use derivatives and will adjust these values of M and C, then find the error. Again, adjust the values of M and C and find the error. Maybe square error, mean square error is 21,000. So like that, the algorithm should adjust the values of M and C and keep on computing the error. Now, if I plot the errors on graph, how many parameters are there? M and C. Based on M and C, we'll get some mean squared error, or I'll simply say error. For a combination of M and C, I'll get an error. Now, if I try to plot a graph, how many dimensions are there? 3 dimensions are there. If I try to plot a graph in a 3D graph, maybe it is difficult to visualize in a 3D graph. So this is M and this is C and this is error. If I try to plot for combination of M and C, what is the error? In a 3D, it is difficult to visualize, but I'll just draw. Maybe initially the error is this much. As the algorithm runs, the error will try to reduce. At some point of time, the error will again start to increase. For a given M and C, actually this is a 3D diagram. It is difficult to visualize, so I'm showing you like this. So for each value of M and C, we'll calculate error, and if we try to plot, the error will slowly decrease. And at some point, after some point, the error will start increasing. So we have to identify this point where the error is minimal, right? So we have to write an algorithm which will adjust the values of M and C such that once it finds the minimum point in the graph, it will stop and then it will tell, okay, at this particular value of M and C, we got a minimal error. So it will fix. Now we have equation price is equals to M into area plus C. And we have identified, our algorithm might have identified at this point what is the value of M and C. So once we have the value of M and C, if you are given area, we can easily predict what is the price, right? So we don't need to actually write the logic for all this. Actually, I told you that to adjust the values of M and C, the algorithm should use derivatives internally. It is not like random M and C. There is some logic which the algorithm uses, right? So in this case, I was telling that the error starts decreasing gradually, right? Right. If I follow this. So this technique which we follow is called as gradient descent. Hey, if this is a curve, can I find slope of this curve? Maybe you're all mathematics student, right? How do we find a slope at a particular point in this graph? Anyone good at mathematics? If you remember, how do we find a slope of a particular point in this graph? We draw a
Uh,
tangent.
M would be equal to uh, phi 2
No.
minus phi 1.
We will draw a tangent at this line.
Yeah,
Tangent.
yeah.
And it will
Tangent from the
intersect
line.
and we'll find the
Yeah,
theta. I hope you remember slope is equals to tan theta. If you are a mathematics student, otherwise if you don't, forget. Slope is nothing but tan theta. We draw a tangent at this point, find the theta, tan theta is a slope. And at this minimal point, what is the theta? Theta is 0, right? Actually, because both are parallel, x-axis and this line are parallel at this minimal point. Tan 0 is what? 0. Tan 0 is 0. That means at this point, the slope is 0. So here in this case, initially there was some slope. Slope gradually decreases. Another name for slope is gradient. If you know, another name for slope is gradient. So the slope keeps on decreasing, decreasing, decreasing until it becomes 0. So that is why this technique is called as gradient descent. The gradient of this curve keeps on decreasing, and at some point the gradient is 0. We have to identify this point where the gradient or slope is 0. So this technique is called as gradient descent. And in machine learning, there is an algorithm called as linear regression algorithm, which internally uses gradient descent technique to identify the value of M and C at this minimal point.
Where
Okay,
theta tends to 0. Dy by dx, theta tends to 0. Understood.
exactly.
Yeah.
Exactly. If you remember your calculus, is dy by the derivatives is 0. Yes, correct. Fine. So any queries till now about the technique of gradient descent? So actually what? Again, I will repeat so that maybe you'll get the idea into your mind. Yeah, tell me, Konar, tell me.
Um, Only one thing. Let's say this. If you look at this data now, what happens in a real-time scenario? These are the housing prices in area. So there is in reality, what happens? There is, let's say, luxury housing coming, and then there is a affordable housing side by side. So if we
Mhm,
just look at this, area and price
mhm,
for even for a particular locality where
mhm.
luxury housing might be like it's just double the price
Correct.
uh, versus
So,
the uh,
yeah.
you got it
So the
right.
price is not only, you mean to say that the price is not only dependent on area, price might be dependent on various factors. Maybe the
Yeah,
society where you are
actually,
buying,
so
maybe the
even
number
if
of
this will,
bedrooms.
yeah,
Hmm.
sorry. So even if this will fit a slope, it will give us some model, but using this technique regression, right? But then when we try to fit it, it will may not be like predict properly.
Correct,
I'm not
correct.
sure, but just
So
thinking it might
right
happen. But
now, right now we are training our model to predict prices only based on price, sorry, area.
Mhm.
But in reality, the price is not dependent only on area. In reality, the price might be dependent on various other factors, right? So
Hmm.
maybe let me just show you one more data set. Just give me a minute. Yeah, this is a little bit realistic scenario where I can say the area of a house is not only sorry, the price of the house is not only dependent on area, it is also dependent on number of bedrooms and age of the house also. As the age of the house increases, price decreases, right?
Hmm.
So assume that, see, basically how we are training our model. Are we training our model to predict prices based only on area or on various factors? So however you train, the model will predict accordingly only, based on whatever data you train.
So maybe model has find out who hey this equation is not linear. Means or that we have to judge like okay no this data not looks a linear regression, so
Ah,
let's not try to fit a
so
algebra
yes,
this linear regression but try another technique. I'm just asking, not
exactly,
sure.
exactly. In machine learning, there are hundreds of algorithms, hundreds. So based on the data set, you need to decide which algorithm to use. If you find that the data is having some linear relationship, then only you have to use linear regression. But if you find differently what is the relationship, then you have to use different algorithm. So here right now I'm talking about only linear regression algorithm to just give you an
Mm-hmm.
idea. But there are
Their
hundreds of
main.
algorithms for
Mm-hmm.
different kinds of data sets. Maybe linear regression is not good for some other data set. You have to use
Mm-hmm.
another algorithm, right?
Or Siva, there might be like tools available which can look at my data and then automatically find out is it a linear or a hyperbolic, or and then automatically try to apply the ML algorithm by their own. Not even like I'm just
See, first of all, training
again
has
I'm
to be
not
done
saying
manually, right? No, first of
okay.
all, training has to be done manually. It is not only
Mhm,
giving data. You have to set some parameters for training,
mhm.
right? So you have to decide. It is not automatic. Based on the
Okay,
data,
okay.
your ML, if you are an ML engineer, you have to identify what algorithm is appropriate, configure that parameters, and then start training. Training will take hours or days, right? It is not automatic.
Okay, understood. Okay, thank you.
Fine. Now, if I take this data, price is dependent on area, bedrooms, and age, right? Mhm. There are, see, earlier when it was only area and price, I have drawn a 2D graph with X and Y axis. But now there are four parameters. Maybe now I need to draw a 4D graph, is it? It was very simple to visualize a 2D graph, area on X axis and price on Y axis. But now there are four parameters: area, number of bedrooms, age, price. So maybe I need to draw a 4D graph. In 4D graph, I need to find the line equation, right? So the line equation might refer like this. Price is equals to M1 into maybe area plus M2 into bedrooms plus M3 into age plus some C. So here in a 4D graph, my algorithm needs to identify M1, M2, M3, and C, right? So this will be the equation for this one. So of course, 4D graph, it is difficult for us to visualize, but the algorithm can easily find out the values of M1, M2, M3, and C. Okay. Now I wanted you to visualize one thing. What is real? How do we think this M1, M2, M3, and C? What is the real impact? Hmm. See, whenever we are deciding the price of the house, think logically, uh, which will have more weightage while calculating the price. Definitely the area, how much is a square feet? A square feet, based on the square feet, the price will be decided. But the impact of price will be more on area. So can I say that while calculating the price of the house, more weightage has to be given to area? Yes.
Yeah.
So in this case, whenever I say M1 into area, this represents the weightage given to area. We'll be multiplying with this weight value, right? So when calculating the price, I can say this M1 represents weightage given to area. M2 represents weightage given to bedrooms. M3 represents weightage given to age. Maybe M3 might be negative. Why? Because as age increases, it will have a negative impact on the price. The older the house, price also will become less, right? So in this case, maybe M3 might be negative. So basically, I want you to visualize this M1, M2, M3 are nothing but weightages given to these features: area, bedroom, and age. So when I say I am training a model, what do I expect after the model is trained? I want the model to have the values of M1, M2, M3, C, right? So I want you to visualize. Suppose if I say this is a trained model. This is a trained model. That means after training, it might have identified what is the value of M1, comma, M2, comma, M3, comma, C in this case. So once I say that I have a trained model, I want you to visualize that weights are computed. And C is also, you can think of a type of parameter. All these weights and C, we call it as bias. In machine learning terminology, we call this M1, M2, M3 as weights, and this C is called as bias. So basically, when I say I have a trained model, during training process, I want you to visualize weights are calculated, bias is calculated. So these weights and biases are called as parameters. So whenever I say I have a trained model, during training process, weights and biases or parameters are calculated. So now can you visualize? I have a GPT model which is trained. GPT model is a trained model. GPT, pre-trained. P stands for pre-trained transformer, right? Generative pre-trained transformer. It is a trained model, right? Don't you think that there will be multiple parameters? Let us go and check how many parameters are there. I wanted you to visualize actually how costly it is. I'll go to ChatGPT. Wait, why is it taking this much time? Yeah, I'll go to ChatGPT and ask on how many parameters are you trained? What is your model name? Let us see. It is saying I am based on OpenAI's GPT-4 model, specifically GPT-4 Turbo. And how many parameters it is saying? 175 billion parameters. So when training GPT-4, it has to compute 175 billion parameters. You can assume how much computing it will take, right? Actually, to train GPTs, it will take months, right? It is a huge computing power, huge data will be there to train. So I want you to understand, once I say that I have a trained model, that means weights and biases are calculated. Hey, right now I told you I created this model using this linear regression algorithm, right? But GPT is not using that linear regression algorithm. We will see tomorrow that internally it uses something called as neural network. We'll see. Don't worry about GPT right now. Just I gave an example, but I hope now you will be able to visualize what is a trained model. Once I have a model which is trained, that means all these weights and biases are calculated. And I wanted you to identify that training will be costly in terms of time and resources as well. So training a model has to be done only once. Once training is done, we have all the weights and biases, right? They have to be saved onto a file, persisted onto a file. Okay, training is done. All the weights and biases are persisted. Now, what I can do, I can load this file and then create a model again, model object. Basically, it is all object. By using this weights and biases in the file, can I recreate this model, trained model? Yes. So by using this file, I can load and create a model. I can say that this is a instance of a trained model. So that means once a model is trained, we'll reuse it by loading the weights and biases. So training is done only once, and then we reuse the trained weights and biases, create a model, and use it for predictions. Okay. Now, just a minute. Now let's assume that I have a model which is trained. Now what? If I give area number of bedrooms, and age as inputs to it. What will be the output? In this case, it will output the price. That means my model can predict the prices. Remember, the predictions might be wrong as well. Internally, these predictions will be using probabilities. Okay. So remember, models will only predict. See, let me go to GPT. Here I'm in Chat GPT. Here there's a warning. See, Chat GPT can make mistakes because this GPT also will do predictions. It will try to give a predicted answer, but it might be wrong. So remember that models will always do predictions based on probabilities. They might be wrong as well, but most of the times, if your training is good, if you're trained on good data, the probability of that answer being correct will be more. So that's about basics of linear regression. Now let us try to implement it. Theory is over. Let us try to implement it and let us create one trained model so that you can visualize whatever I said. And then we'll go on to the next model, right? So what I wanted is on your machines, you need to have Python installed. And I want you to install Python version 3.12.9. Actually, the latest version is 3.13.x. Don't install this 3.13 Python. Please install the latest version of 3.12, which is 9. Because we are going to learn some frameworks, agentic frameworks. And there is one framework called as Crew AI, a very interesting framework, which is not yet compatible with the latest version. So if you install 3.13 on your machine, Crew AI will not work. So to make sure that all the frameworks work on your machine, I wanted you to install 3.12.9. So I'll just Google for Python download. The first link I will take, download Python. So the latest version is 3.13.2. So if you're looking for Python with a different voice for Windows, let me just click on this Windows. Here you can see there are releases. I wanted you to download this 3.12.9. This is the latest one, but this is the one which we want to use. You can download the corresponding installer and then take all defaults and install. So once you install Python on your machine, if you type Python dash version, you should be able to see Python 3.12.9. Take all defaults and install. Just download the installer and install it whenever you are working, not now. Then we'll be using a tool for writing our code, VS Code. I'll just Google for VS Code download. So after I Googled, I'll take the first link, VS Code. Yes, based on your operating system, you can download Visual Studio Code on your machine. Take all defaults and install Visual Studio Code. I have already installed Visual Studio Code on my machine. So I will just open this Visual Studio Code. This is a Visual Studio Code which is already installed. So I have opened, okay, already since I have used it, it is opening some folder. So for what you can do is once you open, you'll get a welcome screen actually. Then I wanted you to open one folder. So what I will do is in my C drive 2025, I have created a folder Agentic AI Workspace. Maybe I'll create a different folder. I'll create a new folder. April 2025 agentic AI workspace. Okay. So I want this folder to be my workspace. I'll copy this path, open the VS Code, go to File, Open Folder. I'll give this folder, whatever I created. So the Visual Studio Code will open. Oh, wait. Open folder. Yeah, I will select this folder. So it has restarted and now Visual Studio Code is showing the welcome screen. I'm in this folder, April 2025, Agentic AI WS. This folder. Right now, this is empty. So I will start creating my first program which uses linear regression. What I can do is I can create subfolders inside it. So I'll create a new folder with name 01-ML. So here I'm going to write all MN related programs. In this, I'll create a file. Python files will be with extension .py. But for practicing, I'll create a file with extension ipynb. Let me show you. I just create a new file, linear reg dot ipynb. Okay, this is not .py. I'm creating notebook. Let me just ask ChatGPT. What is ipynb? Interactive Python notebook is a file format used by a software called as Jupyter Notebook, which is an open source tool for writing and running Python code interactively. Okay, ipynb stands for Interactive Python Notebook, and this is used by something called as a tool called as Jupyter Notebook. It is a tool for writing and running Python code interactively. So if I want to run some code interactively, that is the reason why I created ipynb. So I created this folder. Okay. Now what I want to do is, let me tell you, maybe as some people are new to Python, let me just tell you a basic. Just a minute. Yeah. So what I want to do is, I wanted to do some installation. I wanted to install some modules of Python. How to install modules of Python? Okay. Let me just tell you what I can do is I'll open command prompt and I will install. Let us say I will install pip install. This is a command. Pip is used for installing Python. Pip install. Suppose if I wanted to install scikit-learn. Actually, this is a Python module which contains the machine learning algorithm scikit-learn. Suppose if I install, let us see what will happen. Pip install scikit-learn. I'm just typing. It is saying that the requirement is already satisfied. Scikit-learn is under this folder. Under this folder. Let me go and check that folder. Yeah. Under, see this folder, C drive users Shiv Prasad. This is my user drive, app data, local program, etc. So all the libraries will be downloaded under this folder. All the libraries. Whatever libraries I install, they will be in this. Let us go to scikit-learn. Yes, this is the one which got downloaded. Scikit-learn, this one. So everything will get downloaded. Now I'll tell you a problem. Maybe if people are knowing Python, you might be knowing, but to make sure that everybody understands, I'm telling some basics. So suppose on my machine, I am using 3.12.9 version on my machine. And I wanted to work with a framework called as LangChain. Or maybe I will just tell you one more common thing. Let us say there is something called a SERP API. Just for example, SERP API. There is one module called as SERP API. So assume that I am working on a framework called as LangChain. LangChain is dependent on SERP API module. It internally uses SERP API. For example, I'm saying, and LangChain needs SERP API version 1.3, for example. Then I wanted to use one more framework tomorrow. Let us say I want to use Autogen. This is a different framework, but it needs, of course, let's assume that it also is using internally SERP API, but it needs 1.4 version. So different modules or different programs might want different versions of the libraries, right? So actually what, suppose I want to see pip show SERP API. It will show the version of SERP API is what? Right now, whatever is installed is 0.15.6. Now, suppose if I again do pip install SERP API, what it will do is, it will download whatever is the latest version today. And it might be 0.1.6. So what? The previous version will be uninstalled and the new version might be 0.1.6 might get installed, right? So if 0.1.6 is there on your machine, let's assume till today I was working on LangChain. I'm okay with SERP API 1.3. So this is SERP API 1.3 is on my machine. For example, now from today, I wanted to use Autogen, but when I installed Autogen, as it is dependent on SERP API, it downloaded the latest version required for this one 1.4. Do you think if I run this LangChain application, do you think it will run now? May not run because this requires 1.3, but whereas right now the current version installed on your machine is 1.4, there might be incompatibilities, right? So to avoid such things in Python, what we do is we create something called as a virtual environment. So maybe for application 1, I will create one virtual environment. And maybe for this is venv1, I'll say. Maybe for another application, I'll create another virtual environment 2. This is for app 2. So whenever I am running app 1, I can activate venv1. And whenever I'm working on app 2, I can activate venv2. So in this venv2, I can have SERP API 1.4 installed. And in this, I might have SERP API 1.3 installed. No problem. Whenever I am running app 1, I will activate virtual environment 1. Whenever I'm running app 2, I'll activate virtual environment 2. So no problems. So in Python, we use virtual environments whenever we are writing our application to avoid such conflicts, right? So I have this folder right now. Let us go to C drive. 2025, I have created April. This is the workspace which I created. I wanted in this folder, I wanted to create a virtual environment so that all the libraries will be downloaded into this. How to create a virtual environment? Let me just show you. I'll go to command prompt. Okay, sorry. I'll go to command prompt and I have to execute Python. Already I have Python installed on my machine, so Python is recognized. -m venv. I'm saying that I want to create a virtual environment with whatever name I want. I will write Siva. I'll say April 2025 venv. This is the name of my virtual environment. So once this command is executed, I will see that a folder gets created in this. Let us wait. It is creating a virtual environment. I'll show you one program today. Linear regression. Yes. Oh, sorry. I'm in this folder, is it? Seed have. Oh, sorry. I think I will CD to that. I did a mistake. I was in this folder. This April 2025 VNV got created in C drive user save Prasad. No. I wanted to CD here. Then I wanted to execute that command so that the folder got created here. See? So this is my virtual environment folder. Now if I go inside it, you can see that there is a lib folder, scripts folder, include folder. In this lib folder, you can see site packages, only this one right now. And if I go to scripts, there is a script called as activate. So if I want to activate this virtual environment, what I have to do is just execute that script. Right now I'm in this folder. I'll just say /April 2025 env /scripts/activate. This is the one which I'm executing. If I execute this, see, you should see like this. April 2025 env. That means I have activated this virtual environment. Okay, now I'll go into lib and see here, I will just right now install pip install scikit-learn. This is the module which contains machine learning algorithm. So I'm installing this scikit-learn. Let us see what will happen in this case. I'm in lib folder. You can see site packages. You can see right now there is NumPy downloaded automatically because scikit-learn is internally using NumPy, right? Just let us wait. It is actually downloading joblib, scipy libs. See, if I'm installing scikit-learn, this scikit-learn might be dependent on other modules. So all the dependent modules also will be downloaded and installed in this virtual environment. Okay, let us wait. Still it is downloading this and installing this. Let us wait until this command is completed. Yep, done. Installation is done. Scikit library is installed in this virtual environment. Remember, you have to see this to make sure that you have activated the virtual environment. And if you run any command now, that will be executed on this particular virtual environment. Okay. Now, coming to my VS Code, let us see how to make VS Code to use this virtual environment. I opened this this one. It is automatically saying we noticed a new environment that has been created. Do you want to select it? Yes, I can select. Or here I can click on select kernel Python environments. Here I can see that there is April 2022 VENV because see, I'm in the same folder, it automatically detects. Okay. So I selected this virtual environment. Now, we don't need to open the terminal outside of VS Code every time. What we can do is we can go to view and terminal. Here it will open the terminal as well. I want a command prompt. I'll go to this drop down and select command prompt. Okay. Now I want to activate the virtual environment which is present in this folder. So I'll write /April 2025 venv/scripts/activate. This will activate the virtual environment. From now onwards, I'll not be launching the command prompt outside. We can launch the command from command prompt from within the Visual Studio Code, and we can execute the commands here itself. Okay. Okay, I'll close this command prompt. I have activated. Let it be. I can open it anytime whenever I want. I'll close this. Now I made sure that my notebook is pointing to this virtual environment. Okay. Now I wanted to actually have some sample data. What I will do is I have some file. I'll copy paste. This is a file which I have. It's a CSV file. You can see that area, bedrooms, age and price. This is a CSV file. Right now I have very less data. Normally for training purpose, we'll have huge data. Right now, just for demonstration, I have this CSV file. And using this CSV file, I want to train my model. Let us see how we can train it. Now in this notebook file, I can click on markdown, and if I want to write any text, I can write the text here. So suppose if I want to write a heading, I can use #linear regression and press Control Enter. It will execute, and this is a markdown which is getting displayed. So I can click on markdown to write some markdown, and if I want to write some code, I can click on code. I can get the code cell. All right, fine. Now I wanted to load this CSV file. So I hope if you have done some basic Python, you know there is a library called as pandas. So I'll import pandas as PD. And I might want to use NumPy, another library. See, automatically this editor is suggesting what I want. Mostly whenever somebody imports pandas, they might be using mostly NumPy. And I wanted to use an algorithm called as linear regression. So I have to import it from sklearn. I installed scikit-learn library, right? From sklearn, I can import linear model. Okay. So I'll be using some functions and classes inside this linear model. So I have done all the imports. I can click on this link or press on Control Enter to execute it. For the first time, whenever I execute a cell by pressing Control Enter, it is asking me this requires IPy kernel package install. To execute this cells in notebook, it is saying that I need this IPy kernel. It is installing. Now you can see here in this virtual environment, some other libraries are getting installed. Because see, I selected this kernel, right? Whatever it is installing right now, it gets installed into this virtual environment only. Okay. So it will take some time. We'll just wait until this IPy kernel gets started. is installed and it is ready. Let us wait. Just a few more seconds, 10 to 20 seconds it will take. Yeah, maybe because for the first time we are installing in this virtual environment, it is downloading a lot of files. Maybe let us wait until this is done. Yeah, done. Now connecting, yes. So now I got an error, no module found pandas. So I need to install pandas. Whenever you want to install anything, whenever you get such a error, you have to install that corresponding module. I'll just go to terminal again. And I'm in this virtual environment already. This virtual environment is activated. So I'll do pip install pandas. So it install that pandas library. Let us wait. Wait. Still installing. Yeah, done. Now I'll close this terminal and let me try to execute this. Control and enter on your keyboard will execute the cell. Yeah, it is importing. Just wait. For the first time, whenever you are importing, yeah, you can see tick mark. That means this cell got executed. Fine. Now I want one more code block where I want to load this CSV file. So using pandas, already I have imported pandas. You can use a function pd.read CSV and pass the CSV file name. Home prices multiple dot CSV. This is a file. This will return me an object of data frame. Data frame is like a table. I'll just print the data frame. Yes, this is the data. I got it as a table. Data frame, you can visualize it like a table. Fine. Now, I want you to introduce you to terminology. How many features are there? Area, bedrooms, and age and price. If I have to plot it on a graph, I need a 4D graph, is it? 4 dimensions, area, bedrooms, age, price, etc. Now, what is the thing which I want to predict? Price. So I'll call y as price. Right? On y-axis. Normally, whatever we want to predict, we call it as y-axis. And maybe area, I can make it as, let us say, x-axis. Bedrooms, I can make it as some z-axis, etc. There might be 4 axes, right, in 4D graph. So when whatever we want to predict, we will call it as y. I want to predict prices finally, right? Y is price. And there might be multiple axes, right? There might be 100D graph as well. Maybe it is difficult to visualize a 100D graph. It might be possible, right? It is especially not possible to identify a 100D graph. So whatever parameters we have, we all call it as capital X. Capital X contains all the input features. Okay. Okay. Let me introduce you to a terminology. Right now, I have expression price is equals to M1 into area, M2 into bedrooms plus M3 into H plus some C we call it as bias actually. Now I have this, I'll call this price as Y, and area, bedroom, age, we call it as input features, right? These all are input features. Now, can I represent all these three, area, bedrooms, and age, as array matrix? Matrix. Let us see. First of all, let me visualize it. Okay. So what I will do is I will just say df dot df dot drop. I want to drop price. Axis equals to columns. I want to drop a price column. So after dropping whatever I get, I will call it as X. Okay, let me try to display X. Yeah, I dropped the price column and the remaining whatever I have is X. Now if I see this X is also a data frame. If I call X dot values, I will get a 3D matrix, three-dimensional matrix. It's a matrix, right? Maybe, sorry, not matrix. You can visualize it as an array, 3D array. Three dimensions are there: area, bedrooms, and age. Right? So I have this input values as a 3D graph, and I want to get Y also, only Y values. Y is equals to df dot price. Let me display the value of Y. Y is again displaying as data frame Y dot values. I got it as an array, right? So I now have X values as a three-dimensional array. Y values is a single dimensional array. Now, very simple. If I wanted to actually use linear regression algorithm on this data and train, it is very simple. What all I have to do is I have already imported linear model. I will create an object using linear model dot. There is a class called as linear regression. I am creating an object of this class. Regression model. This is a predefined class, regression model. And to just use this algorithm to train, very simple, reg model dot fit and pass X and Y. That's all. Calling fit by passing X and Y will do the training. As I told you, what is the process? It will start with a random value of, it will start with a random value of M and Y. And the values of M and C, and values of M and C will be adjusted by following gradient descent algorithm. I told you whatever, right? We don't need to worry about all that. We just create an object of linear regression and call fit. It will perform training. That's all. Let us see. I just run this. Calling fit on this object and passing the data will start the training. Now the model is trained. If you want to get the values of M1, M2, M3, very simple. You have to call regular this model dot predict. Simple. Model dot, sorry. Yeah. First of all, if I wanted to actually get all the values of M1, M2, M3, I can call model dot OF. Oh, this is M1 value, this is M2 value, this is M3 value. M3 is what? Age, right? Did you recognize that age is negative? Yes, right. As the age increases, it will have negative impact on price. These are all the weightages according to the data whatever I provided. I provided very less data. Based on that, the training is done, and these are the values of M1, M2, and M3. If you want to get the value of C, C, we call it as intercept. I'll call reg model dot intercept. This is the value of C. It's a float, this value. Oh, so once I called model dot fit, it is calculating M1, M2, M3. These are the values, and I got intercept value. Now, how to do predictions? I want to predict the price of a house with some area and all. Dot predict. Wait. Yeah, dot predict. So what? Model dot predict. I have to pass this array. First argument is what? 3000 square feet area. Number of bedrooms is 3. And age is 1 year. I want to predict. Let me run. What is the value? 650, 582. This is the price of a house for 3000 square feet area, 3 bedrooms, and 1 year old. Suppose if I want to predict multiple values for multiple houses, maybe I'll have to give, it's a 2-dimensional array, right? I have to give one more dimension. Maybe for 3500 square feet, 4 bedrooms, and 10 years old house, I wanted to predict. See, I got two values. First one is for 3000 square feet area, 3 bedrooms, and 1 year old. Second one is for 3300, 4 bedrooms, and age 10. So once we have a trained model, we can call predict and pass the X values. We'll get the Y values. That's it. We're able to train the model. Training the model is nothing but calling fit. And during training, as I told you, I want you to visualize that the weights are calculated. M1, M2, M3 are weights. This is bias are calculated. Once these are ready, we can call predict to predict the prices. So this is an example of linear regression algorithm. I hope this is clear. Let me know. Today we just understood this. Maybe tomorrow we'll take our next step. Yeah. I'll be sharing this in my Google Drive. Wait, I'll just tell you. I'll go to my Google Drive. Okay, I'll go to my Google Drive and I'll create a folder for you where I'll be sharing all the files, whatever exercises I'll upload here. I'll create a folder 2025-April Agentic AI. So here I'll keep all my files. I will share it with you on WhatsApp. I'm making it as restricted access. I'll give you the link on WhatsApp. Right now on the group, I am actually giving this link. Please, all of you click on the link and request for access. I will approve only for our training people. So in this folder, I'll be keeping my files, which you can actually use. Whatever programs, today is very small program. I'll give you this program. You can actually work on it. Or today you can ignore. This is very simple things. Maybe I will share these two files. You can just go through it, set up your Visual Studio Code, set up Python, create virtual environment, and just do whatever I have done in this video. You can watch this video. By tomorrow, we'll start with neural networks, deep learning. We'll understand about it, right? So today I wanted to conclude with this basic machine learning. Tomorrow we'll understand about logistic regression first, then neuron, then neural network. We'll understand how neural networks work tomorrow. It's very interesting tomorrow. I'll catch you up tomorrow. Yeah, if you have any queries, let us talk.
Uh, one so this like we have fit this model using this py file. So
Hmm.
like when we like download some file, then we have like some extension like .exe or .msix or something. So if this model is trained, and if I want to take out this model and
Uh,
like run it as an independent, so it's like
no.
some kind of
See, in this case, model is one object which we are using, right? This is an object in Python. So what you might have to do is, if you want to reuse this trained model, you have to save this model into a file. The object we have to save it into a file, and maybe in another program we might have to load this from the file and recreate this object. So Python
so
means it is either .py or .ipynb. Yeah.
mhm. So that
Hmm.
when I take this model in some file, so that will the file extension of that file
If you
like
save this object,
means there will be like some different extension. Okay, this is my dot model file.
yeah. So again, there is no such standard for
Okay.
serializing. We call it as serializing. We have to serialize that. So normally in Python, we write a file with .pickle. This is one of the standard. There are a lot of things, right? We can actually write that object or serialize that object to a .pickle file, which will contain the weights. This .pickle file, it contains all the weights, M1, M2, whatever, in some format, which we don't need to understand. And what you need to do is you need to load this pickle file and create that object again. This process is called as deserialization. So again, this .pickle is just one format. It depends how you write. It is up to you. Right now, we are not discussing that how to write it and how to read it again. That becomes very big. That is not our concern. Just
So,
understand.
so
Okay, we'll save it to file and
Mhm.
read it. Read it. Yeah.
I'm thinking like when this model we put that dot fit function. So
When we
this
call that, yeah.
hmm.
The
So
it is an object
after
now.
that,
Hmm.
yeah. So after that, like this model file, maybe inside it's just an equation with and M1 and M2. So it will like very less in terms of space that
Right.
will
In
save
this
the model.
case, okay, don't, I'll use right terminology. This is an
Mhm.
object. This object will have M1, M2, M3, and something else like C and all. So right now, this is very small. This model is
Mhm.
very small, very few parameters. How many? Four parameters are there: M1, M2, M3, and C. But whereas GPT, I showed you 175 billion parameters are there. So to save that model itself, it will be huge space. They are big models.
So
Okay.
we can debug this model like just the code like we if it is a .py file of some logic, I can click on this and I can see the logic.
Yeah, of
So
course, of course.
similar way,
Of
this
course, if I
model
control,
file.
see, if I control and click
Mhm.
on it, it will take me to the .py file. This is the class, linear regression class. If you want to see the logic, whatever is there, you can just go and see it. What is there inside fit? You can see.
Okay, understood.
Control and click. Press your control and click on it. It will show you the code.
No, no,
And
this
where
is
is this
a
class? Base.py. It
okay.
is in the virtual environment here.
No,
It's
this is a
open.
linear regression thing. What I am saying is that model which we called upon fit. So this reg model dot fit
This is an
xy
object, right?
reg. Yeah,
This
yeah.
is an object.
So.
I am showing you the class. This is the class.
Hmm.
An instance of this class is nothing but the object. Object internally contains the parameters M1, M2, M3. That's what I'm
Yeah, so
describing here.
that
Coefficient. This is
yeah,
coefficient. This is
yes.
interest. These are the values. M1, M2, M3 and intercept. These are the actual values. We can see that.
Okay, understood.
Okay. I stop the recording. Yeah, if you want to have another discussion, yeah, you can